Hello. Oh, my name is Mikołaj Dadela, and I would like to give a quick talk about fetching the data. I think this is a very common problem in modern web applications, where the API is a separate part from the front end, which runs in the browser. So the problem is that the front end needs to access the data from the backend somehow, and that the front end needs a quick and an effective way to get all a quick and effective way to get all this data. And the very common approach for this is creating a REST API. So in our team, we had an idea that we want to rewrite some parts of our application in Node.js, and we wanted the REST API, and we started designing the REST API, and we had some problems with it. So the first approach is, OK, so we will have a page with a discussion topic. And this discussion topic has some entries and has some title. So let's say that the endpoint will return the title and the messages. And the question is, OK, but then what then when I want only the entries, or I want only the title? So there we thought about the second approach, which is also a common one, I think, where we have small endpoints that deliver only very small pieces of data. And when we need something like the entries, so for example, I get the topic, and the topic endpoint returns IDs of the entries. And then I send another request to get the entries. But well, actually, both those approaches suck, because the first one sucks because most of the time we will be fetching more data than we actually need, because we will be for example, for a topic page, we need a lot of data, but sometimes we need just a very short summary that, hey, there is a topic with with this title, and this is the last message from the topic, and so on. So we needed to balance somehow the data that we want to send. So we wanted to avoid sending too much, but we also wanted to avoid sending too little, because when we send too little, we do round trip to the server very many times. So and it's like we send a request to get the topic data, and inside the response we have IDs of the entries. So we make another request to get the entries, and then in the response we have IDs of the users that wrote the entries. So we send another request to get the user data, and then we can have the avatar URL, so browser can send its final request to display the avatar. And this doesn't make sense in big apps. And I did some research on the internet. I looked at some, better structured approaches for making REST API, like the JSON API, like the HAL, and some other ideas about specifying REST APIs with references, but they seemed very complicated and not really solving our problems. And actually, some of them were just specifications without even working code. So that's not what we wanted. And so the solution we wanted would be something where we can where we can run queries like, I want the data about the user that wrote the first entry in some topic, and I don't know the ID of the entry. I don't know ID of the user, but I know that he wrote the first entry in the topic. So the only thing that seemed to solve the problem was the GraphQL from Facebook. And a few months ago, when I started this, I watched the presentation about GraphQL, and I was pretty excited. But they said that, we think that we will release it to the public sometime, but we don't really know when, and expect it to happen soon, but it didn't happen very soon. So I decided that we need something, and my idea was simple. My idea was that all the data that we have in the server, and we need to access it in some way, is some kind of a tree. So So in the root of the tree, I have, for example, the collection of topics, and the collection of entries, and the collection of users, and the collection of books that we have on our site, and, well, everything else. And it's inside the collection, so this is the one branch. Inside the collection, I have the topics, and then each topic has its entries, and each entry has, well, they have references to some other things. So I thought it makes sense to make it one big tree, and make queries based on paths in this tree. So I could write queries for things like topics.123, .opening entry, .author to get the user data. To get the user data for the user that wrote the entry. And what surprised me that it was actually pretty easy to implement. So that following those references. Well, basically, the whole point of this presentation is that it is an open source project. Well, I want to make it an open source project, and my boss has agreed on it, and I'm looking for some people that would like to help with the project, maybe, well, participate in it. Because I think that I think that this project, even in the current state, is pretty exciting because we have some. So the front end consists of React components, and those React components can make requests for tiny bits of data, and then those tiny requests are accumulated in one big request that is sent over HTTP to the server. So this request contains a list of references in the tree that we want to fetch. And then the server looks at all those references, resolves those references, so it means that the author of this opening entry is actually user 123, and it merges all this data into one big JSON, and it sends it back to the client. And then the client merges this big response into its own store. And this way, the client can maintain its own copy of the store. And this way, we also avoid fetching the same data more times, and we also avoid many HTTP requests. We avoid those round trip problems, and it's, well, all in all, it's pretty effective. And it's totally independent of the front-end technology that we use. So in our project, we use React, but you can use anything you want because, it returns just a promise, and you can put it anywhere you want. Also on the server side, this library depends on very small functions that get those little bits of data. And it works server side, so it's much faster than, well, sending a lot of tiny HTTP requests. So it all happens on the server. Yeah, so I think that's it. I'm open to answer any questions. So, well, if anyone is interested in participating, I would just ask you to come to me here during the conference, or just talk to me on GitHub or by email. And I forgot one of the main points. So, because of the whole data structure is a tree, I decided to call this library a squirrel because it jumps over the tree to fetch all those references. So that's why there's the squirrel. But yeah, thank you.
Hi, I have a question. You said, if I understood correctly, that you gather all the queries, combine it, and make one request to fetch the data. And what if there are many changes on the page in a certain amount of time? Do you collect it during some part of the time and send a couple of requests, or do you wait? I don't know, how did you manage that?
So actually, the method that works now is I I work until the current piece of code is executed. So in JavaScript, it's just set timeout to 1. So I just wait until the current piece of code finishes. So it means that all the component code runs before I send this request. And so theoretically, it could, I'm setting the timeout to 1, so it's not it's not really 1 millisecond. It should be it will be more, but I just wanted to wait for all the components to initialize, and then I know what do they want. And sometimes after they fetch some data, they want some more data. So I send another request. So yeah, it happens. But the idea is that, for example, in the application that I'm developing now, normally during the page load and initialization, there are 4 requests sent actually. But it's still good because there are 4 instead of 40 requests for all those little bits of data. So I think that's still a good result, and I think also that it can be improved. So I did investigate it further why we sent 4 requests instead of just 1, but I think it's still a big improvement. By the way, the same thing. So this happens in the front end. The same thing happens also in the back end. So in the back end, every little branch, so every little part of the path is connected to some little procedure that fetches this data. So those procedures have to be specified by the user of the library, but usually they are just as simple as here's the topic ID, and I want the ID of the first entry in the topic or so. So they usually, most of the time, they boil down to one very simple SQL query. But those procedures are to be specified by the user of the library, so they can use anything. They can use a relational database, they can use MongoDB, they can use Elasticsearch, or whatever.
One of the main features of the HTTP 2.0 standard is going to be using one connection, one request to aggregate multiple requests for data. Aren't you afraid that with the coming of the new standard, the HTTP 2.2 standard, your library will become obsolete?
I don't think so, because batching those requests into one is just one of the features, and the key. So this is kind of a side effect. So it's a very nice side effect, but it's more like a side effect. The whole point for us was to organize the data and let the front end query the data they want. So that the front end actually the components ask the server for the data. But it's not like each component sends its own request for the data, because many components will ask for the same data. And it would. So maybe the problem with having a lot of requests it's not a problem in HTTP 2, but we still have a problem with organizing all this stuff and deciding what data should we put in our REST response. So this was the first problem that triggered this whole thing. That we couldn't decide whether we should keep our endpoints small and simple to just send the tiniest set of data that makes sense and reference everything else by IDs, or whether to build huge endpoints that return everything that might possibly be needed in the future. So usually. So the first side of the spectrum has problems and it sucks. The second side of the spectrum sucks also. What people usually do is that they try to make REST endpoints more or less closely based on their views. So there is the topic endpoint for the topic page, and there is the topic endpoint for the stream view on the main page, and so on. But this also sucks because this binds your API logic to your front-end logic, and your front-end changes a lot. And we don't want to change the API every week when some new designer says that, hey, I want this to include also the entry text, for example.
So can I just open Firebug and download your entire database?
Theoretically, yes.
Okay.
Theoretically, yes, but actually the decision is to make in the procedures that the user of the library, the developer will specify on the server side. So on the server side, you can put any trigger you want. So in our current setup, this library handles. So we have on the server side we have the endpoints, which is actually just one endpoint that gets a list of references. And then it calls the squirrel thing. And so there is the endpoints layer, there is the squirrel, and there is the database. So there is this tiny layer of SQL to actually fetch the data. But those are very small and simple procedures. We have a lot of them, but they are very small and simple. So those two layers, the endpoint layer and the database layer, are both in your control, so we can do whatever you want. So I didn't want to build it into the library, but you can do it outside it.
Okay, thank you.
Yeah.